How's it going? This is Sam Welker with thinkparticle.com, and in this video we're going to be talking about creating particles in Houdini with a color that sticks with them through their lifespan. So there's a lot of ways to do this, and we're going to be rendering it in Redshift in the end, but we're going to talk about a specific way that solves a few problems. So before we get started, let's go ahead and just take a quick look at thinkparticle.com. ThinkParticle is a site that creates tools and training for artists. And we've released a lot of products over the years, and have had our products used by many companies, ranging from many freelancers around the world to studios like NBC, actually not NBC, sorry, well maybe NBC, CBS, Nintendo, and Pepsi, and yeah, lots of companies. Anyways, and you can check out thinkparticle.com for more information on that. But there's going to be a lot of other training there as well, which you can check out. Learning Cinema 4D, Houdini, different other tutorials as well. But let's go ahead and jump into this tutorial now. So let's go ahead and see what this is first. So for starters, what we're going to be creating today is a particle simulation that will emit and have particles kind of fly out. But as you notice, with previous tutorials I've colored particles based off of their based off of curl noise before, but never did the noise, or excuse me, the color that it received when it was given that stay throughout its entire lifespan. And it's just not a very appealing effect to me. So I thought I'd make another tutorial on how to actually have that color swirl sort of look stay in with the particles. And we'll go ahead and break this down, and then we're going to render it with Redshift. So if I go ahead and just hit render really quick with the IPR, and this is final render quality, by the way, so it'll take just a moment to render it out. But this is what you can expect to see out of this tutorial, more or less. So we're going to change some colors and the look of it in general, but let's go ahead, and what we're going to do is create a new scene in Houdini and just start fresh. And I'm going to go ahead and set the project and save the file really quick. Alright, so I've saved it, and we're going to go ahead and get started. The first thing we're going to do is actually just hold Control and hit the sphere in the top left menu. And for those of you that have watched my training before, sometimes I skip over some of the details, but today I'm going to try and go a little bit more into detail about specific shortcuts and things like that to help people get a little bit more comfortable with Houdini, because I know when I was learning, that made a big difference for me. So we have this sphere in the scene, and I've just selected this camera icon right here, so now when I click and drag in the scene, I don't have to hit any buttons or anything. I can just control the camera in the scene, and if you look at this gimbal in the bottom left, I'm actually rotating around. And we're going to rename this, and really quick, how to set up this layout. I'm going to cover that too. Let's go ahead and, I think I've actually changed the default. This is interesting. But let's go ahead and talk about how to set this up really quick too. So normally when you jump into Houdini, I'm pretty sure it looks something like this. And what I've done is I have Alt-clicked right here and then clicked right here without Alt to just change my layout. And then I also have done, I've also split this view right here to add a render view, a geometry spreadsheet, animation editor, help browser, and asset browser down here. But honestly, I don't really use them that much. So just a quick tip on how to do that. So we're going to rename this just by double clicking on the name and name it particles. And this is where we're going to generate our particles. This actually won't be rendered. We're going to be using an instance object to render our particles with a little sphere, because we're going to be using Redshift. If you were using Mantra, you could actually skip the instance, and particles actually render natively in Mantra. And they don't entirely render natively in Redshift just by hitting render. You actually have to set it up, but it's really easy to do, so we'll go ahead and take care of that. So we're going to just hit tab and create a pop network. This is a particle operator network, and just go ahead and get started by jumping in. We can double click on it or hit I to jump in, and we're going to go ahead and start out by setting our first setting, and that's what's going to give us the opportunity, or I guess the ability to create particles with a specific color at birth. So this is going to be our just born group, and we're going to give it a name. And we just type it in, and that's all it takes. So the next thing we're going to do is set a pop color, And we're actually going to change this later and take out that node, but this is just for demonstration purposes. I'm going to set these to be red, and if we just hit play, and I'm actually going to add a pop force as well, because I want to move the particles. So we'll set that to probably an amplitude of 2, and maybe of 1. And we'll turn up the particle count. Okay, so that's the particles right now when they're just born. And if we set this group name to born, then it should only apply this color to particles that are just born. So if we hit, I'm not sure if we can actually, I'm not sure we can animate this. So what we'll do is we'll do a pop-up. And what we'll do is we'll just set this up really quick. We'll hit L to display all of our nodes. We need to lay them out properly. And this is a vex operator. What it is it's a visual way of connecting different items. In this case, we're going to take the, well, actually, we'll just set the color first. So let's go ahead and get a constant. And this constant is going to get set to a constant type of color. And we'll just set it to plain, actually, we'll set it to red. And then we'll get a color correction node and plug that in to the CD section, and that's the color section for the output. And then we'll middle click on the shift parameter over here and promote that parameter. So that's a complicated way of setting up a hue shift out of the pop-vop, which we can now access up here. So promoting the parameter brings it up one level. So let's go ahead and just review what I did really quick. We are birthing the particles, and we gave them a group, which is being accessed by this pop-vop because we've checked this box and labeled the group. And then the pop force will move the particles. So if we just hit this flag on the end here, the pop force won't actually move the particles. But if we hit play, you can notice that the particles are colored by the pop-vop, and they are moving based off of the force. So let's go ahead and we're going to animate with a quick expression this hue shift. So we're going to just type in $F \450. And that's going to take the current frame and divide it by 450. And that's going to move these particles over time so that when they emit, they'll actually have a different color. And if we change that to, say, 30, you'll see the effect a little bit more prominently. This rainbow is being emitted, and it's very colorful. Maybe we should set it to 150 to kind of ease it up a bit. But this is how you can emit just basically particles over time emit particles and change their color over time without having the particles actually lose their color as they get older. Now, there's another way to do this. And I'm going to use the pop color node again, and we're going to just plug it in, and then I'm going to use a switch operator in this case, just because it's good to kind of get familiar with all these nodes. And we're going to just set this up so both the pop vop and the pop color plug into the switch operator. So the switch operator is just kind of a bypass comparator. So we're going to set the switch operator to 1, so it's going to take the second input, which is the pop color node, and just when you select that, you can see them right here. And we can actually leave that unbypassed. So we're going to take the color, and we're going to set to ramp. So now we're going to set the initial color, and then we'll go ahead and set the ending color as well. And now we can hit play and see these colors apply to these particles. And we could set the born group for this one, but that won't work. Because if we do, then it'll never adapt that color. So we do need to pull the range down a bit. So if we set this to 0.5 and 1, or 0.25 and 0.75 maybe. Oops, let's go up. This will give us a little bit more of a harsher gradient as these adapt, and it's not working, so let's do 0.25 and 0.5 maybe. And we'll try 0.1 and 0.2. Maybe 0 and 0.1. Okay, so the particles are turning yellow as they get older. but that's a dynamic effect. So these particles aren't keeping a color attribute as they get older. And they're actually starting as red and then they turn yellow, which is a great effect, very powerful, very useful, but not for everything. So what if we want to give a color at the very beginning and have it keep it forever? So that's where this just born group comes in. So let's make this a little bit more complicated. And the way we're going to do this is we're going to set this up, and we're going to just delete these nodes we've used already and go back to the beginning. And we're actually going to just start by plugging the age into the color, and we're going to add a few nodes in here. So we're going to add a fit range, and that's the first node we're going to add. And then we're going to add a ramp parameter. And what these two are, I'll explain them very quickly, is the fit range is for ramping your values. So if your minimum value is 0 and your maximum value is 1, for the range of the input, you can map that to be 0 and 1 on the output, or you can map that to be 0 and 10. So say our value that comes in is 0.93, and we've mapped it with this setting right here. 0.93 will come in through the source minimum, where 0 is the minimum and 1 is the maximum, and it will stretch that minimum and maximum from 0 to 1 all the way to 0 to 10, and that will be 9.3. So it brings it up. But if you change that so that the minimum is 5 and the maximum is 10, then that'll change the value, and it'll be, gosh, I'm actually not exactly sure what value that'll be. I complicated it, and anyways, doesn't matter. That's how it works, and you can map the values through here. And then also we're going to use a ramp parameter, and what that is like that promoted value earlier that we used. This is going to give us, it's a way to create a user interface item without actually having to go into the parameter interface settings. What you can do here is create a ramp, which is used in your on your VOP, your pop VOP node to control your vex operator, your pop VOP. And this can be used as a spline ramp with the settings just built in right here with this checkbox of a ramp type, or excuse me, drop down, or it can be an RGB ramp, which can take vector colors, or a vector value, which is a color in this case. So we could set it to be an RGB, or we could set it to be an HSV. We've got a lot of options. So what we're going to do is we're actually just going to stick with the regular settings and set it to RGB. And we're going to take these values, and I guess technically we don't really need the age value. But we'll use it anyways just for this case to kind of demonstrate the purpose, and we'll disable the born group. And this will show that these particles will apply the same way that this other color group works. So if we have our particles shoot out over here, you can see that they're working. And if we have our particles shoot out over here, you can also see that, well, they should be working. Maybe if we turn that value down. Okay, there we go. And if we just watch this now, our particles turn black because of this ramp gradient. So it's basically like setting up this ramp here. But what we're going to do now is set this up so that our ramp is going to be, well, I mean, there's a few ways we could do this. We could set it off based off of the age, but I think we're going to take a curl noise, and we'll set the curl noise based off of the position to control the color. And we'll just kind of change the frequency. We're going to pull it down a bit, kind of scale it down to 0.6, which actually gives us a more regular color pattern. And you can see these particles are now having this curl noise effect applied to them in the 3D space, but it doesn't change. And that could be cool if you're using, curl noise to represent different values in 3D space. But this would be more of like a UI sort of effect maybe, but it doesn't really move, and I'm not super huge on it. So let's go ahead and apply this effect at just the very beginning. So now when we hit play, these effects stay, and they never change because we haven't set it to change. So what we have to do to set it to change is to promote that parameter through the offset, and then we can just right click on this first box and paste relative references on the rest of them, so we only have to set the value once. And pasting relative references is an expression which is basically saying just copy that box in this case. So let's set this to f divided by 60, or $f divided by 60, which is another expression to say I want you to change one entire frame count every 60 frames. So it's going to take the current frame divided by 60, and that'll give us our value for our offset. And let's also take the turbulence, and we'll take the turbulence octaves, the turbulence, and bring it down to 1 instead of having it at 3, because it breaks it up a little less, and I didn't really like how it was breaking it up during our color tests. And we can hit play, and let's make sure we hit this real-time toggle on the bottom right. This clock will actually say, as we hit that, it will play back in real time, or at least as close to it as it can. And now our colors are staying. So we want to go ahead and make this a little more usable and art directable. So what we're going to do is use a color mix node. And what this will allow us to do is select the second color, and we'll just promote that parameter, and we'll promote the bias. And what that's going to do is we can now affect our particles that are being emitted based off of this color, and we can say we want it to be 50% red, everything that comes out. So you get this nice variety of warm colors. Or you can bring it up to say 0.85, and then everything's pretty red, and then there's just a little variation in there. Or you can bring it down to say 0.1, and it's just going to tint everything just a little bit. So in effect, we're creating a color tint. So we'll bring it probably about 7.73. So it's a nice variety. And we've got a good effect here. And that's really all we need to do. I actually built a different setup in my last rig, but this is the same exact effect that we have. And we have this this color that's now applied to our particles based off of a noise. And we could, adjust that noise. We could just go in and hit, add a little bit of extra code to that expression. We could offset the noise. And if we want to, we could also promote the frequency parameter. And now what we would just need to do to move that, because I do want it to move up a bit, we just have to go up and drag it and drop it in the parameter interface settings. So we'll just hit accept, and now it's up there. And we can just move it up, and we can just change it on the fly. Now the variation is going to be a little stronger because we turned it up. And yeah, so that's how we create the colors. So the next thing we're going to do is set some settings. We're going to set the amplitude of the noise to 0.5 and the turbulence to 3, and probably leave all of the other settings at default. And then we're going to grab an axis force, a pop axis force specifically, and drop it in. Now let's talk quickly about forces for those of you that haven't worked with them before. In the PopNet, you're going to find two different types of forces, and you can only use, well, you can use both, but I recommend using one usually. So you have your normal forces, and when you watch my older tutorial about creating custom vortex forces, it's going to give you a lot of control, and it's really useful to be able to create a vortex spline-based force. And there's a couple of ways to do that I've learned since then. And you can use these forces in here, but they're a lot slower. But if you use the pop forces in the pops net, so you have your regular forces for everything, then you have your pop forces, which are used for forces for particles, but also for crowd simulations. And we'll talk about that a different time. But the pop forces are a lot quicker. So a pop axis force is going to be a good friend for us here. So you have this sphere, and this is where the particles are affected by this force. And as you can see, they're starting to spin when they come out. And if we turn up that setting, you'll see that they spin when they come out. But if we turn it down, you'll see that they only spin in the sphere. And then they kind of keep their regular velocity at that point, which can be a really cool effect. But in this case, we're going to want to set that outer strength to keep, here, let's start this back over again. We're going to set the outer strength to 1 so that when they leave that sphere, they're still spinning. And the reason it stops spinning is because the sphere is a fall off. And if you set the inner strength, meaning the dead center, to 1, and then the outer strength, after you get outside of the sphere, this little bounding box, this red bounding box or bounding sphere that comes with it, if you set that to 0, it won't affect anything outside of it. But if you set it to 1, everything in your scene gets affected by this central point. And you can affect where this is based off of this, and you can set which direction it faces, or the normal of the fall off based off of the axis direction. So if you want to spin sideways, you can now have your particles spin in a different direction based off of that axis first, and now they're spinning there, which is great. I'm going to keep it on the regular axis, just y-axis 1, and we're going to set the suction speed to 1, so that way they spin but also kind of get pulled towards the center, so it's kind of like a gravitational pull. And they'll actually grow in the vertical axis as well, going up and down, which we'll keep for this, but that's what's going on. And one other thing I did was I had an attractor, a pop attract force as well at the beginning. And this is actually used with just the Born group. And I set it to something like 10, maybe 100. I think it was 10 for the initial force. So now the particles, when they're born, they'll come to the center. And then they will spin and have turbulence applied to them. Based off of the pop force and the pop axis force. And it kind of breaks up the color and everything. And if you look at this, the particles are all spinning in a circle now, and they're all very displaced and turbulent. But it gives a very nice variation. And if you wanted to, say, go to the pop and pull the frequency down a lot and change the pop force turbulence to 1, you could probably get a little less color breakup and everything, and it'd probably be more like these consistent swirls when it spins around. But the variation in the visuals are going to be very different. So just some ideas there. And that actually looks pretty cool. It's nice and soft and friendly. But at Think Particle, we don't like to be friendly, so we're going to turn that back up, and unless, of course, we're doing tech support, then usually we like to be friendly. And we'll go ahead and go with those original settings we had. So that's how we create those particles. And trying to think if there's anything else we want to cover. There is one other thing I like to do. And we actually technically already covered this, but we're going to just go ahead and take the color correction node, and we're going to drop it on. And just hit L to lay out everything. And just on a side note, one thing I did in my last setup was I actually took the curl noise and I used a color correction node, and I set the saturation to 0, and then I multiplied that with another color to set the color. So it wasn't actually using the curl noise. So I was actually wrong about that. It didn't affect it in that sense. I was using the ramp parameter settings I built earlier, so we can go in and check that out in a bit. But, this is pretty darn close anyways. So we're going to just promote that hue shift parameter again, and we're going to type in $F, capital F, underscore, or excuse me, not underscore, backslash 300. And the only thing that this is going to change now is it's going to take those colors that we put in, and it's now going to take everything put into this setting and change the color or change the hue over time. So it is going to give it the full course of a rainbow, and you can see that it started out as kind of a red value based off of these kind of particles over here at the end. Then it turns yellow and green and then kind of cyan, and now it's getting to a deeper purplish, darker hue. And that's really cool. This is very powerful. We're going to turn up the particle count to really demonstrate this. And with the variation applied, it just gives you a very wide variety of control and a very wide variety of color and look. And maybe you don't want that much variety, but that's something that you can add in and benefit from. So we'll go ahead and delete those channels and just kind of leave that color as is. We don't even have to get rid of the hue shift in this case. We'll leave it there in case we want to change it later. So we have our purplish, reddish, yellowish particles, and it's pretty cool. So we've got our particles, and that's great, but now how do we render it? And today we're actually going to be using a setup called, or a renderer called Redshift So let's go to their website. I'm going to give you a little bit of a sales pitch. Not sponsored by Redshift whatsoever. I even purchased my own copy. They didn't gift it or anything. This is my top choice for any rendering platform. I've used Octane and Arnold before, and they're very powerful, very wonderful renderers. Highly recommend them. And Mantra is really great too. I highly recommend that as well. But Redshift is easily my favorite because you get the power of something like Arnold or RenderMan on a GPU. So you get the speed of Octane with the power of those other renderers, and anything that would take a while to resolve on Octane usually renders a lot quicker on Redshift. And actually, one more quick item here, and then I'll stop wasting your time with this. There is this setting here called Out of Core Architecture. And when you're working with a GPU renderer, you have to be able to fit everything on your GPU in other GPU renderers. But as far as I'm aware, at least on Octane, unless you're working with textures, which can then be placed on RAM. But I'm currently working on a 2 gig GPU, and I've got a couple of 4 gigs out of my machine right now that I haven't taken the time to install, and I'm planning on upgrading as well. But I've got a pretty simple GPU in my computer that would run you about $150 right now, and I can render everything on this GPU because it can also spill out onto the RAM. So that's one of the nice things about Redshift that I think is very valuable. So there's my sales pitch. Highly recommend it, and for $500 you're getting a great deal. So we're going to go ahead and start by making a material. And we're going to just type RS in the shop network. And the shop network is the shader operator, which is where you create your materials. It's very, very powerful. And you can do a lot of stuff with it. And we're actually going to dig a little bit into a custom material for this setting. So this is the RS material. It's kind of the Uber shader of sorts. It's the ultimate shader for anything. And we're actually going to use the incandescent the incandescent material for this render. But the RS material is, basically just about anything you can think of for adding to your material. And if you need to add textures to it, you see all these colors here. You can actually just type allow editing or, go up. These are Houdini digital assets because that's how they were built. You can right click and then set to allow editing of contents. And you can then jump into it, and in here you have your material node, which you can then hit this flag right here, and you can see all of the different settings you can control with something like a texture. So if you make a texture and you drag it in and you want to apply it, you can actually just drop it in right here, and these are the main inputs right here. And you can actually control your diffuse color, your emission color, your opacity color, things like that with textures or different values. So that's how you can control an incandescent material as well. So we'll just drop in, and this one actually is a lot less intimidating with numbers of inputs. And we're going to set an RS particle attribute lookup node, and that's a complicated term. Basically, if you're looking at a particle color, or if you want to affect particles based off of their particle attributes or point attributes, this is the RS particle attribute node. You also have the vertex attribute node, but if you're affecting particles or any points, then that's going to be based off of the particle attribute node. And this is going to just take an attribute name, and you can plug that into the color of your incandescent material and then jump up and actually control it. And we'll probably set this intensity multiplier to 10. And we'll just go ahead and apply this we're actually going to apply it to a sphere. So we're going to go ahead and create a sphere and apply this material. And to render in Redshift, you have to have a few things. So the first thing we're going to do is create a camera, and we're going to pull the camera out and get a nice view of the particles. Cool. And we're going to take the sphere, and this sphere is going to be our particle. We're going to set it to 0.0005, pretty small. And that will be the scale of the particle. We'll just call this particle geo. And then we're going to hit I while it's selected, or just double click on it to drop down into it. And we need to make sure that this is a polygon mesh or a polygon so it can be rendered. And I'm just going to set the polygon with a frequency of 2. So it's got enough geometry to look good as a particle, but not too much geometry to clog up the system. And the next thing we need to do is have an instance object. So really quick, let's cover this again. We've gone into our shopnet after creating our particles, and we created our material. And now we're creating our particle geometry and instancing that geometry onto our particles. So we go into our instance node, and what you can do in here is you can actually instance your particle geometry onto whatever's inside of the instance. And we're going to take our particle geo and set it to full point instancing. And if we just disable our particles really quick and turn up the size of this sphere, you can actually see this instance right here. So, the instance is, right here. If we took our sphere and moved it, I guess that actually applies to transform. But anyways, it applies based off of this point right here. So we're going to go ahead and take an object merge node. And the object merge node takes different nodes from different areas. They're called SOP nodes, and they're in that's the wrong button. Okay. They're in the object network here, and we're going to go ahead and use the object merge node to grab the particle geo, or the particles geometry SOP here. And this is just our particles that we created, and we're now going to be able to reference those as our instance object. So now our instance geo is now going to instance onto these particles. So if we turn this on or off, you can see these particles are now controlling the position of these little spheres, so which are actually way too large. We'll pull those down, and we can just hit play, and you can now see that these particles, though they're moving much slower now because it's geometry, are now moving based off of our particle sim. And it's nice. You'll probably think, well, the size of those isn't accurate, but the color of those isn't accurate, but we'll set that. And the one downside to this workflow is it's not set till render time. So if we uncheck this, unless you watching know how to do that, feel free to correct me if I'm wrong, but I don't know how to set the color at the current time. So we need to make sure our material is applied, and then our particles, which we can view the color of just by actually viewing the particles themselves. Also, quick tip, when you are playing back, you want to make sure your particles are what you're viewing, not the instance object, and it'll go much faster. Then you can enable your instance itself and select it, and in the settings, you need to set the object parameters from Redshift, and this is in your just Redshift shelf. And you need to do two things. You need to make sure that you're using the Redshift point clouds, and then you're going to need to use the particle attributes, which are in the point attributes. So under Redshift object settings attributes, you can go and set the CD attribute and the V attribute, and that takes the color attribute and the velocity attribute and applies it to these points. Okay, so that's complicated, but it works. And now we have to do something. This is the hardest part. We hit render, and it doesn't work. So that's because we forgot to hit the Redshift button. And what that does is it goes into our out net, and that's our ROP network, our render network. And it created two different ROP nodes. And this is the Redshift ROP node and the IPR node. And the IPR node you don't actually ever touch. All the IPR settings are in the ROP net, so you can just pretend this doesn't exist. And we'll just pull it off screen because we don't need to focus on it. And your IPR settings are in your ROP net at the very end. So quick introduction to Redshift. You have your main settings. This is where your camera is, or if you're overriding your camera resolution. Your output settings is where you can say whether you're going to overwrite mplay images. This is when every time you hit IPR, it's going to open up mplay, which is kind of the picture viewer of Houdini. And every time it renders, it's going to overwrite those images unless you've unchecked it. So make sure you uncheck that. if you're doing a final output. And if you check this box right here, you can actually set the final render. You can change your AOVs here, like your Z depth pass and reflections and things like that. Very useful. Depth output, very powerful. Under the Redshift tab, you'll find your actual settings for rendering. And there's a lot of settings in here. We're going to go ahead and enable a motion blur. And we're going to enable point level motion blur as well. And we're going to enable global illumination. We'll skip the optimizations for now. Actually, we will. Yeah, we will. Because we don't have any reflections or refraction. We could actually just set both of those to 0. And because there's none of those, we can set the combined to 0 as well. And that might make Redshift run just a little bit faster. And, you know, every little millisecond makes a big difference in render time, especially if that's millisecond per particle when you have millions of particles. And we're going to set our brute force, our GI, the primary engine, to brute force. And when you're rendering particles or volumetrics, if you're using brute force GI or really anything, you'll notice that if you have 16 rays, that's basically how many samples you want to reference. And if you change that to something like 512, it'll look a lot better. I'm also going to go into the memory section and set it to use 98% of the GPU power, or memory, I mean, instead of just 90%, because I'm not really using much of anything else. And you can set it to use progressive rendering or just unified sampling. So it's a progressive renderer in the IPR, and we'll show you just by hitting IPR, you can actually see as this pops up, it'll build the scene. And you can see it building the scene now, and once it's done, it's going to go ahead and render. It's really bright. We might need to turn that down a bit. And the particle size down. And this is actually rendering, it's only at 25% right now, and that's pretty slow considering what it can do, because this is a small render that's only 640 by 360. So we're going to set our camera resolution to 1080p. And go to the out settings of the IPR settings and not override the camera resolution, uncheck the progressive rendering, and you will see that those 25 seconds, or those few seconds of, oops. Oh, that's not accurate. It says that there's no GPU memory. So we'll go ahead and hit render again and see if that works. So this is an alpha, and we'll go ahead and this was working earlier, which is funny. I'm going to pause this and fix it because there are bugs still from time to time, but they're never hard to overcome. And if you have a problem with something, you can usually mention it in the forums and on the support forums on Redshift's website. Once you sign in, you can actually access them, but you'll notice that they have new builds. Like I had 2.54 as my current build. And I installed it like 2 weeks ago, maybe a week ago, and they're already on 2.57 with a ton of bug fixes. They're very quick. So anyways, I'll fix this. All right, so I think it just had to sit for a moment. So we're going to go ahead and before we hit render one more time, I'm going to make sure that this geometry is a little bit smaller. I don't like how it's scale. One other note, by the way, when you're looking in the viewport, if you want to see the actual color of the particles, you can use the particle geometry that we've, where we simulated our particles. But if you want to see the size of the particles, if you actually use the instance object, or I guess the density, just using the instances, you can actually view that. So if you're using the just particle color, it's not as good at referencing the actual density, but if you look at the instance object, this is really good at showing you how dense the particles will be. So let's go ahead and go back to the outnet, or excuse me, the ROPNet, and we're going to go ahead and hit render one more time. It's really weird that it was doing that, by the way. I've never run into that issue before. And there it is again. You know what? $5, that's because I'm screen recording. Quick disclaimer, that's not an actual bet. All right, so I've turned down the percent of GPU usage, and we'll see if this works. Should solve it. If not, I have one other test I'll do. And I'm going to do this in front of you. Okay, that worked. Just so I can kind of exemplify how to use Redshift and debug sometimes. So this rendered in 7 seconds, and let's just go ahead and note that that is 750,000 particles with GI and motion blur applied. So it's not too shabby, and that's in 1920 by 1080 resolution, so, and I'm sure 4K would be just as quick. I don't have the ability to render 4K in Redshift currently, because I'm on the indie version of Houdini, and Redshift is not currently available on Cinema 4D, but it will be soon. So anyways, let's go ahead and just we'll wrap up, and let's start by going back to the shop net. We're going to just do a few tweaks here. We'll set the particle intensity, the material intensity to 25. And one thing that might help as well is going to the global preferences, and it was talking about having 2 GPUs. We'll just disable the second GPU and see if that does anything, if that helps, and it didn't. So I think the big problem is that for some reason it doesn't think there's any GPU RAM available, but after checking MSI Afterburner, I can tell you that my GPU is currently running at about, I'd say maybe 5%, maybe 4 or 5%. So, you know, it's not really in use, and that's kind of weird. So quick test is, I'm just going to restart. All right, so it seems to be working, and it usually works better when I'm not screen recording, so that may have something to do with it. I don't believe Camtasia actually uses the GPU, so that doesn't make a ton of sense to me. Might just be a bug, but anyways, we're going to go ahead and jump into our camera and kind of reframe it here and see what we can get out of this. And we'll just kind of tweak around for a little bit, and make sure you stick around to the end, because I'll have a little bit of a surprise for you. And we still need to jump into that other scene as well. So you can see that some of these particles have motion blur, and really don't like the look of that entirely, to be honest. Maybe we'll make the particles a little smaller, see how that looks. Let's try zooming out and rendering as a whole. Yeah, it seems to not be rendering all of the particles, and I think part of the reason is because they're so small. So we'll go ahead and try rendering them a little bit larger. Actually, technically a lot larger. They're 10 times as large. Yep, that works. So we'll go ahead and set the value of 0.001 for the render. So we were at 0.25 or 0.0025. So we'll try that new value for the scale. And it seems to catch mostly all of the particles. We'll set it to 0.2 and just pull out. And if you can see them in the actual, viewport, you should be able to see them in the render. So yeah, we'll stick with the 0.25. And we will reference the actual particles for the simulation. Okay, we'll turn on the instance and hit render. Okay, and they're really strong. Visually they are very strong in the render because the intensity multiplier is very strong, and you take that mixed with how large the geometry is now, and it just kind of adds up. And we just need to pull it down a little bit. The intensity multiplier we can pull down to probably 5 at this point, and that should kind of solve our problem. Okay, so that looks a lot better. It still needs a lot of love and tweaking, I think, for the actual color output in the end, but technically this is, what we created, and I think it looks pretty good. It teaches a lot of principles that are very handy and useful as well, and I think that you can take them pretty far. So I did promise that we were going to talk about that other scene, and that I had a surprise, so let's go ahead and start by looking at that other scene, and then we'll talk about the surprise, so you can stick around to the end. And we'll just go to the beginning of the scene. So we'll talk about how the physics work in this really quick by just ignoring the color of the particles. And we're using the pop group. So we have our attractor with our born group, which is called precolor. And we have our pop group that changes the group. And we didn't actually use that in the other in the tutorial, but you can set the pre-color group and change that group later on. And if you want to affect those items below, make sure you set the current group and the new group, and then check preserve color. And our particle force is set to just 0.05, or excuse me, 0.5 for the amplitude. Everything else is default. And the axis force is set to 1 and 1 on the suction and orbit speed, and then 1 on the outer strength. And I didn't change anything else, I don't think. And these are just the default settings. It just so happened to turn out very well. I think the attractor also made a big difference. So I told you that we're going to look at the color settings. So this is what I did. I took the curl noise and I made it completely. Actually, I didn't desaturate it. Excuse me. I multiplied it by red, and I output that color. And you know what? I was wrong. I did exactly what I told you I'd do. I didn't use these settings. So, you know, funny story. That's actually what happened. So also you can take the pop color, and remember you can use this ramp parameter. And if you're not worried about having a particle's attribute stick with it the entire time, you don't have to worry about that. You can use a ramp parameter, the ramp setting in the pop color. So you can actually forget about most of the things we did in the pop VOP. But if you're going to dive into some of the more complicated builds, this is really handy to know about. And one other thing I want to talk about, very last thing, before we get to the surprise, is when you output this color under your particles, you have your color, and it's what's controlling your render, your particle color render. Now, in the VOPnet, in the pop VOPnet, you have a node called the bind node, and you can use this to set parameters, or attributes. So we're going to grab a bind export node, and what this does is you can actually take your value and plug it in, and then you can set this, and this is going to be my attribute, and you can actually take that attribute and then jump up, and we've actually set that to be one of the attributes on the particles. And in this case, that's going to be the exact same color that we're working with. But our instance geometry, where it says attributes, where we have our color and velocity, we can actually now see my attributes in there. And if we delete that and we go in just to prove that it is what it is, one more time, and to make it a little more practical, we'll just call this custom color. And this is something that we could set for an attribute for rendering. And at render time, you can build very powerful shaders based off of custom attributes. And that's one of the most powerful features of Houdini. My current workflow at work, through any freelancing I do or any studio work or any of my personal projects, I always work through Cinema 4D and Houdini as my main tools for 3D, and then I always try to render in Houdini, unless it's quicker to render in Cinema 4D, but Houdini with Redshift is just so much faster and so much more powerful. And now we have our custom color attribute, and if we restart, you can actually see my attribute was down there, and I just went back to the beginning and hit the up arrow key to play the timeline, and it disappeared because we weren't at the very beginning of the timeline, and it didn't reset the simulation, and it was technically applied to those particles. But anyways, that is how that works, and we can just hit play, or excuse me, hit IPR one more time, and you can see that these beautiful little particles will now go ahead and let's go ahead and turn off the instance node. They will now move out, and man, they just look so cool. And you can actually just, let's just go ahead and zoom in. Let's jump into our camera here and zoom in, or dolly in, and just hit IPR. And we could, set the particles to die a lot sooner, but they don't have to live that long. One thing we could do is change the opacity so that when they get to a certain point of their life, they disappear with custom attributes. But I think this is pretty good, and I like it. So we'll go ahead and jump to the surprise. So for those of you that watch this, I don't know if this will be relevant for everybody. Well, we'll make it relevant for everybody. So I've released a new product, and it's called the Mountain Kit. And I've got a few tutorials down here showing you how to use it. And there's a lot of cool stuff you can do with the Mountain Kit. You can get very creative, or you can make, practical mountain ranges with it. So if you click purchase on the website, it'll take you to the actual product page where you can learn a lot more about the Mountain Kit. And stick around and listen to this really quick, because I'm going to tell you that we're going to give away a copy of the Mountain Kit. And if that's not going to be practical to you, we're actually going to let the winner choose between the Mountain Kit or one of our other single products. So we're going to give away the entire Mountain Kit bundle, or one of the other products in here, except for Text Edge Effects. I cannot give that one away. That's actually an affiliate sale. But we're going to give away a copy of this bundle for those watching. And all you have to do is leave a comment below. Just make a remark about the video. You can just tell me how great I am, or anything like that. And we're going to go ahead and let it run for the next couple of days, maybe a week and a half. And starting September 1st, on September 1st, we're going to go ahead and pick a winner. And the Mountain Kit can be used to create a lot of different cool visuals. And you can check it out right now at thinkparticle.com. And we'll even give you a 10% off coupon code if you need to pick it up between now and September 1st for the Mountain Kit bundle. And you can do that by using coupon code IFINISHED. And it's just IFINISHED, so just one word. And you can learn how to create some really cool renders, and you can use it in just about any program. So I think it's really relevant to anybody watching. And if you don't like that, then you can check out other things. If you're a Cinema 4D user, we have a lot of plugins and presets for Cinema 4D, or the Cloud Kit for anybody in any program that works with VDBs. This is a pack of 200 clouds. So anyways, you can win one of these items, or any of these single items in the store, just by leaving a comment below before September 1st. And thank you so much for watching, and I appreciate your time. And hopefully you learned something out of this. And just as an inspiration for your comments, ask questions. What do you want to learn next in Houdini? And we'll go ahead and jump into that. So thanks for watching. I'm Sam Welker from thinkparticle.com, and we'll see you next time.